So just-in-time soil health. Let's see, get this going. It's kind of strange what you remember from your youth. I grew up back in the early 80s, and back then, if you remember, if you're from that time, there was a lot of Space Invaders. It was really the biggest arcade game at the time. I put a lot of quarters in the one at our local 7-Eleven. I still remember the sound when I see that picture that's up on the screen. I remember the sound from that, which is probably not a good thing. I can still hear that in my head. But for some other reason, I also remember something else from that time, and it was called just-in-time management. I remember a change that Toyota was making at the time in the way they made cars. And making cars is a complex process, which with each of the parts needing to be available on the assembly line, like you see here, at just the right time. And so what they were doing at that time was storing all these parts in large warehouses, which is expensive. And so this is how they did it back then. In the old system, parts were delivered to these large warehouses whenever they were ready, enough to keep a good supply on hand. And then the parts, let's see if I can get here, the parts were delivered as needed to the assembly line. And at the time, to get around that expense of these large warehouses and the inventory, Toyota implemented this just-in-time management. So the parts were delivered just on time, either to a smaller warehouse or directly to the assembly line. As you can imagine, this required much more detailed management and coordination between the parts makers and the assembly line. And I happen to remember this when I was preparing to write a blog post on how much soil organic matter is enough. And I happened to see some similarities. So in the soil, if we think about carbon as the inputs from plants, that's kind of our parts for the cars. The cars are, the output is the functioning of the soil that needs energy to run. That's over here. We call them losses, and we try to maximize this and minimize this, but maybe that's not the best way to think about it. We need this carbon energy flowing through the system, and whatever's left over kind of gets stuck in this soil organic matter storage pool. But just like maintaining a large warehouse of parts, building and maintaining a large storage pool of the soil organic matter can be difficult and expensive. So at the risk of comparing the soil to car manufacturing, I think there's an idea here to consider. What if we focus more on this flow through the soil and not so much on this total soil organic matter? And that's where this just-in-time soil health comes in. So back in 2006, Henry Jansen, a researcher in Lethbridge, Alberta, wrote this important paper. And he wondered whether we focused too much on the soil organic matter storage and not enough on the flow of organic matter, or the flow of carbon, that carbon energy through the soil. Because as he observed, we get many of the benefits of organic materials as they decay, as they are processed by the soil microbiology. As the plant material provides that energy to the soil biology, that's where we get the function, which is what we want in the soil, at least part of it. So Toyota produces cars. What's the product in the soil? Well, the product here I mentioned is carbon losses, but it's the soil microbial life and functions. That's what really we want. The microbial life is dependent on the flow of photosynthetic energy from plants, which is what this quote basically says. So as important as soil microbes are, they're fueled by plant food. And if it could be done, we would want the benefits of the energy flow through the soil, but without the need to build and maintain a massive warehouse, if you will, full of organic matter. So we want just-in-time soil health. So think about it. The parts and materials of the soil are photosynthesis, produce carbon, really the energy in the soil. And the soil organic matter is the soil's warehoused inventory of energy. We have particulate organic matter, that's sand-sized particles of organic matter. They're kind of like a nearby warehouse, and so they're more available for use. The organic matter on minerals, so clay and silt surfaces, that's kind of like a warehouse that's further away, less available. And just as with a factory, it's increasingly difficult and expensive to maintain a high level of both of these types of organic matter in the soil. So we have carbon demand, which is productive and unproductive carbon losses. So unproductive up here, that's what you're going to get from tillage, looting our soil warehouses basically for some short-term gain, but at the expense of lost inventory. And these are the losses that we want to minimize. But a lot of the losses are actually productive. It goes to soil biological function, maintaining soil structure, suppressing soil-borne pests, making nutrients available. All of that, that's productive energy use. And that's what we want here. And if you look at that, the soil microbial life and function, that all equals up to soil health. So as all good metaphors are, this one breaks down eventually. Unlike a factory, we cannot be very exact about the demand and energy flow rates in the soil, but we can make an educated guess about when the extra just-in-time flow would be useful and how we might provide such a flow. This question here, when? So here's how it could work. If we provide enough just-in-time energy, we will attain the desired soil function and reduce the need to maintain high inventories of soil organic matter. The key to this, just as in a factory, is an accurate forecast of that demand. When is it needed and how much? The demand here is the flow of that photosynthesis-derived carbon energy through the soil. How much is needed to provide the desired function? Then we need to be able to provide that enough energy, and we need to do it at the time when it's needed. So that's where the just-in-time comes from. Since timing is what we can manage, when do we need these just-in-time carbon flows? Some of the flow is going to come from soil organic matter decay. In fact, a large bulk of it. But this is going to depend on temperature and water. So it's going to be a lot less in the winter, early spring, and the fall when the soil's cool. And once a crop gets established up here, it's going to provide carbon flow through root exudates and sloughed off roots if you're talking about a perennial crop. So the crucial stage, in my opinion, especially in reduced tillage systems, is during crop establishment. So from planting to seedling establishment. And the demand here for soil function is high. You've got your seeds germinating, you've got your roots growing, your shoots emerging, but the cooler soil temperatures and lack of living plants can limit the energy flow from decomposition of our warehoused soil organic matter. So this is when it might be particularly benefit to attempt to ensure a good just-in-time flow of this carbon energy. Once established, again, the photosynthesis and the seedlings can begin to produce their own flow of energy into the soil through root exudates. And the soil energy flow for the rest of the season is provided by the exudates and organic matter, as I said before. Before we go on with this, we should ask why would we want to do this? And it's back to that expensive warehouse. If we can do this, perhaps we can have improved soil health without more stored soil organic matter. Now there is some benefits that are particular or they're specific to stored organic matter, and that water capture, water storage, some of the structure. So this is not going to make as much sense possibly in some irrigated or some systems. In irrigated soils where you've taken that water factor away, in sandy soils, low organic matter soils like where I am in Washington in dry climates, if we can have increased soil health without having to build that soil organic matter pool, that's going to be a big benefit. You can see the importance of soil health here, and I've got to talk about this, is going to be greater in your rain-fed dry regions, a little bit less in your rain-fed humid. But when you take that water factor away, soil health is less important in irrigated conditions. It's not important, but it's less important because you don't have those water benefits from the capture and storage that you get from soil health. So another reason we might want to do this is to compensate for low carbon flow in periods, even if you have higher soil organic matter soils. So this is the early spring, late fall, when the soil temperatures are not conducive to the decay of that organic matter. You might have a lack of that carbon energy flow. And finally, I mentioned soil-borne disease suppression. It's thought that the plant carbon inputs are important for this disease suppression, especially what they call general suppression that comes about from the stimulation of an overall microbial community. So the more general activity we have by beneficial microbes, the less chance that other microbes can cause disease. This is a mustard green manure that we grow here in Washington. I'm going to talk about that a little bit later, but it's an example of how this might be used. So how can we provide this just-in-time carbon flow? And the use of living plants is probably the easiest way. And one of those methods is, you've probably heard of, is planting green. So direct seeding a crop into a stand of living plants. The just-in-time carbon energy flow is provided by root exudates and then the dead roots during crop establishment. So some combinations work better than others. There's nitrogen factors, rotational factors, but this is one way that just-in-time carbon flow or just-in-time soil health could be provided. Relay crops are somewhat similar, and this is where where the growth of one crop overlaps that of another. You know, I get wheat, soybeans is probably the best known, especially out in your region. It may not be as important for just-in-time soil health because here where they're overlapping, the soil temperatures are quite warm, and so you're getting a lot of that flow from just your storage, that warehouse of soil organic matter in the soil. I mentioned this before, the green manures. So this is carbon flow from dead plants. And consider this what we do in the Columbia Basin of Washington. So this is a late fall incorporated green manure crop, and it provides just-in-time flow to an early planted potato crop the next spring. It starts with a large amount of green, easily decomposed biomass incorporated into cold soils, which slows the resulting burst of microbial growth, perhaps just enough to make it effective for those potato seedlings in the early spring when the soil begins to warm up a little bit. So the resulting flow improves, we've shown this through research, improves water infiltration, resistance to wind erosion, and provides some soil-borne pest suppression in these low organic matter soils. And when I say low, a lot of our soils are below 1% soil organic matter. So although these effects are really not very long-term, they may only last a month, 2 months, 3 months. They're often enough to get the potato crop that we plant in the spring established and to close canopy before they dissipate. So that's that general suppression of soil-borne pests. So from dead plants, also from organic amendments. Applying organic amendments, not just broadcasting them, but applying them at or near the seed or developing seedling. This is a pelleted compost product that's being developed in our area. They put it right down with the seed in the seed furrow, and it puts some quick available C also and slow available C right down there with the seed where it's needed. So it's kind of a precision compost. It's going to provide some of the benefits that I've talked about from the just-in-time carbon flow. It's much different than a bulk application, though. We're putting on rates that are not going to change your soil organic matter level. They're more after that, those immediate benefits, the just-in-time benefits, I guess you could call them. So then there's combining carbon source with fertilizers, and you're seeing more and more of this out there. I think they're better than the biofertilizers because this is actually feeding the microbes you have, and you know those microbes in your soils are well adapted to your soils. Here's one. This is from Wilbur Ellis, and I think it could be one of these products that provides just-in-time soil health earlier in the season. Applied later in the season, you may not see it because you've got all that flow from both your crop roots and from the organic matter itself. So we've been focused on this period here, the crucial time of crop establishment, but there's another time the strategy could help, and that's after crop harvest. And this is where cover crops are the main practice here, or overwintering cash crops like wheat or barley. So again, from living plants, cover crops, this is a field of arugula. You've probably eaten arugula in salads. Our farmers actually use it as an overwintering cover crop in our region. It's a brassica crop. They use it for nematode control and just as a regular cover crop. And it provides that carbon energy flow throughout the winter and into spring. So location is important for just-in-time soil health. Seed treatments, furrow applications are most likely to have the beneficial effect on seedling growth. So that's where that pelleted compost is applied right in the seed furrow. So just as there are 4 R's of fertility management, they would apply here for these organic amendments for just-in-time soil health. So product, the right rate, the right timing, and the right location. We talked about the times. There's products being developed. The rate is really the difficult one. How much flow does the soil need for good soil health? We just don't know for sure. And it's dependent on a number of factors. With amendments, as we know, if you apply too much carbon, you're going to tie up nitrogen. So there's some considerations there, but there's also some risks. So just as in that car manufacturing example, there's risks of having that smaller warehouse. Having a large pool of soil organic matter is definitely going to be safer. There's a trade-off between the cost of maintaining a larger pool and the risk of missing the timing or the quantity that we need. So we also have to consider just-in-case management. And this is actually what they call it in business too, just-in-case management. So compare and contrast these two. The just-in-case management, I compare it to like having coal or nuclear or natural gas power that provides base power to the more intermittent solar and wind. So it's slow acting, it's continual flow, large quantity, but it's dispersed in the soil. Compare that to the just-in-time management where it's more of a supplementary flow. It's fast acting, short term, much less in amounts, but at a critical time and at a precise location.
Andrew, I'm violating my own rule here, but the molasses and sugar, those quick acting type carbons, and we have people in this area who will put that in furrow. What's your experience with that? What are your thoughts?
Well, there's not a lot of research. When I wrote this blog post on this topic, I went and looked for research on that, and I will actually get to that, Paul.
Okay.
I've just got a few more slides, and one of them is about the research. So just the different practices and the sources. So you've got organic matter decay on the just-in-case management, broadcast manure and compost, crop biomass, your cover crop biomass, cover crop root exudate. So these are going to be on both sides here. But over here, you've got the liquid manure, pelleted compost, and here the molasses and other sugar-based products that are put on. They're not going to last very long, but they kind of give you that quick stimulation of your soil microbes. Green manures are very much the same. You're incorporating them green and lush, and they break down very quickly. I mentioned the relay crops and the planting green. So we have some questions. Just like soil organic matter storage, how much organic matter is enough? We don't know that. We don't know how much flow is enough. And it probably changes over the season, as we've discussed before. One problem here is the measurement of that flow. We don't have a real good, accurate way of doing it, especially because we have such short time periods that we're talking about. It can be imperfectly measured with things like an active carbon test or soil respiration, stuff like the Solvita test. But the problem there is that they only provide you a snapshot of the flow. And so you'd have to do it regularly, and then interpretation is always a problem with these kind of measurements. So I think that's one place where it needs a lot of work. Getting to the research, as I mentioned, I looked at this. So these and other just-in-time soil health managements, they're being recommended. As Paul mentioned, they're being used. Some have been, researched quite a bit, cover crops and green manures, but I didn't find very many other papers on these other types of things like the molasses and the sugar. So back, this 1992 reference up there where they used nitrogen, and this was in potatoes, and they used with and without carbon as straw or sugar. They used sucrose. And they found that the combining of the nitrogen and the sucrose actually increased microbial biomass for up to 25 days. So we're not talking very long, less than a month, but it was enough time for the seedlings to get established. In the next one, the 2006 study, they added glucose. It was a lab. A lot of these are lab research. So, what would happen in the field? You always have to ask that question, but it caused a quick transition. They looked at the microbes, and they had a quick transition from dormant to active microbial states that lasted about 27 days. So again, short term, just stimulating that soil biology. There's some other studies, but then I found this review that was in 2004. They called it Feeding Soil Microbes. It was a section of a larger book. And it reviewed a lot of the research, and it was mainly about using sugars. And they basically found a few benefits, but saw that they needed a lot more research in this area. So Paul, to answer your question, it's still unknown, I think. So a lot of what I've said, and this is a good time to say it, is a lot of what I've said today is kind of speculation. Although the mechanism behind just-in-time interventions, it seems reasonable, at least to me. Whether they can consistently make a difference in yield or crop health or input reduction remains to be seen. The determining factors will be the actual soil organic matter levels, soil temperature and water and crop stage that you're applying them to. So for now, I think both just-in-time and just-in-case strategies are justified. So you want carbon energy flow and storage of carbon organic matter, and they should both be part of soil health management. Here's my contact information. There's a link there to where my blogs are posted, and I'm also on Twitter. Thanks, Paul, for inviting me, and I can answer some questions now.